Thank you, everyone, for attending. I know the Silverado room's a little hidden, so I appreciate you guys making it out here. I wanted to just give some credit to Jean, who's actually in the audience, and Twitter handle @Vinsari, who did a lot of the grunt work, my boss, Dan Clark. And the second visualization I'm going to show you is based largely on the work of Mike Bostock. And today what I want to do is I want to talk a little bit about cheating, which is obviously a very complicated issue. My intent here is to show you two visualizations I had in looking at Canvas data and seeing what we could infer from that. And it's a mix of success and failure, but I'm hoping I'm failing fast, and I'm hoping that you will learn from my successes and failures. And what the context of this presentation is, last year I presented on visualizing student activity within a course. And as I was thinking about what to present this year, I became interested in looking at cheating. Of course, working with faculty, cheating is always a concern. And I found this post on the Canvas user forums, and this is what from a David Spiel, and I have no idea who David Spiel is, but that was his post. And essentially he's asking for an automated way in which there's some sort of trigger where if there's suspicious student behavior, that some sort of report or some sort of visualization is generated, whether it's two quiz submissions from the same IP address, whether it's wrong questions very similar, or two or more at a time. And so that's what he was looking for. So when I looked at it, what we wanted to look at is what we could build with just the Canvas quiz export. Now, there's some, largely because the API is limited. I know there's a lot of API love floating around at this conference, and I don't hate APIs. I love APIs, and we would have done this in APIs, but I think the current APIs are a little limited for this particular. And what that meant by using the Canvas CSV is that an IP address comparison was out, comparing the duration of the exams was out, and automatic was out because of course you have to manually grab the CSV. So I want to talk a little bit about our solution for this, or what we came up with at least. So we have Canvas Quiz CSV to PHP to HighCharts, which is a JavaScript library. So if you go to highcharts.org, you can take a look at that. There are some, there are some challenges with this particular, so I mentioned no quiz duration, so we have limited data. Processing CSV, anybody do that regularly? So we know feel the love of CSV processing, so it can be a little brittle. We're also using PHP. If you don't understand, I invite you to code some PHP and then you'll understand. So there were some limitations and some challenges with respect to getting this off. So if you're ready, I'll show you my first visualization and what that looks like. So here we set up just a standard page, browse, find the CSV, which I've already selected, and then we'll hit the button. And this is how we render. We have on the y-axis, we have the student score. And on the x-axis, this was a limitation of the HighCharts library. We had to choose a single variable to scale on. So we don't have a nice like date, time sort of marking on the x-axis. So what we did instead was set the first student submission as minute 0. And then the rest is indicating how many minutes elapsed from that first student submitting. And then, as you can see, I mouse over, I get the student name, their score, and how many minutes elapsed. From this visualization, we can see 3 data points of interest. These two students, and these two students who submitted in close proximity to each other. Now, of course, that's not... It doesn't mean they cheated. It just means they submitted in close proximity. But if you were looking for patterns or had concerns about it, these data points would be places to go. And of course, you can refer back to the CSV then to look at their answers further. One of the limitations of this, I'll demonstrate here. This is actually the same data set, but with an outlier included. What had happened is a student had submitted well in advance of the others. As a result, the bulk of the data points were compressed at the end. We should also note that one of the challenges just inherently when you're looking at time submitted as a means of detecting collusion among students is that you have an eventual due date. And I don't know, maybe our institution's a little different. I'm sure your students are much better about submitting well in advance of the due date. I'm sure that's a problem that's only at my institution. But so for us, that limitation is that you're naturally going to have, towards the end of the due date, which is hovering right around here, you're going to have those submissions pile up a little bit. So that's some of the challenges with that visualization. Are there any questions about this visualization so far? Okay.
Calculate again the time. It was from the first student submission, and then everyone else was based on that?
Yeah, so the question was how did we calculate the time? And yes, so the first submission is minute 0, and then it's the minutes that elapsed after that, which is why we had that problem with the outlier, because the first submission was well in advance of the others. Yes, sir.
So quiz time span doesn't mean the length of time they took to take it.
No. No, it does not. So the question was, that's not the duration in which they took the exam, and the answer is no, because the Canvas CSV, we didn't have that captured. So that is a limitation we have in this particular visualization. Other questions? And then if not, okay, I'll move on. So I want to go back to the slides. So we talked a little bit about this. So the second visualization I haven't automated yet, but it was based on a paper I came across, this 1992 paper, on a theory of cheating. We have two students, student A and student B, both take the same assessment. They get a certain amount right, they get a certain amount wrong. If they are cheating, then it stands to reason that student A and student B shared the same amount of correct answers and the same amount of incorrect answers. So if you and I are working on a test together and we're just working off each other, then we're going to share the same amount of correct or incorrect. You would hope for the student's sake that if they're going to risk academic dishonesty, that they'd at least get the answers correct. But as those of you who deal with student cheating know, that's not always... The cheaters don't always get the highest scores in the class. So the question is, if you believe this, if for this particular model, of course there's limitations in this, that if you've got a one-off cheating, so a student just asks, hey, what's the answer to number 4, this model breaks down a little bit. But if there's a systematic cheating across an assessment, then there's a question that comes naturally from this. How do you know when there's an unusual amount of consistency between two students? So we can run these numbers in Excel across several different, we could compare potentially every student with every student. But how could you potentially tell at a glance whether the amount is unusual? And so I looked around on the internet, go open web, and I found this. This is what they call a co-occurrence matrix. This is kind of fashionable right now in the digital humanities. And what it is essentially all the characters in the book Les Miserables, and they're compared against each other for how often any two characters appear in the same scene together. So we can see here that with these squares, these two characters appeared together. The darker the color of the square, the more often these two characters appear in the same scene, or in the same scenes. The color was applied to the data prior to visualization using what he calls a community detection algorithm. And I didn't reach out to Mike to ask what kind of algorithm he used, but essentially these colors are used to indicate quote-unquote communities of characters within the book. You can see over here on the right we have we can cluster by name, we can cluster by frequency, so we can sort by the higher frequency characters, or we can sort by cluster. I'll show that again. To clarify a little bit on this data, I neglected to do so. Essentially, you'll notice this, this line running through, and so that's the character being compared against itself. Essentially, this matrix is a mirror half. So this bottom half is a mirror of the top half. The data is repeated because you can compare against this or can compare it this way. It's the same. You're just getting the data flipped and mirrored. So the question I had was, what if I took this and applied it to Canvas quiz data? And instead of measuring how often two characters appear in the same scene, what if I calculated how often two students shared correct and incorrect answers? This was my first attempt at the data. This is from an actual course. You can see again that you have the intensity of the color indicating how often students are have shared correct and incorrect answers. Now, in the first visualization, the color was indicated community detection algorithm. I still don't know what community detection algorithm was used. For this visualization, what I did is coded them by their final grade on the assessment, their score. And we can see here, just with this, I've got them sorted by grade, and now I can sort them by frequency. I found it somewhat challenging to look at both color and the intensity of the color when looking at this visualization. You can kind of look at it, and there's a lot to wrap around. So let's take a look without the grade data being taken into account. And it's with this first data set that I realized there's a challenge with using this visualization to detect detect collusion. And the issue here is this test was fairly easy, and as a result, a lot of students shared the same correct and incorrect answers, which is why you can see quite a bit of red. The standard deviation of scores was low. So I decided to look at it with a different data set. And this is what I have. So this is, you can see this one, what it looks like. And you can, again, through this color, you can kind of get a sense of how students scored based on these blocks. The darker colors indicate higher scores, the lighter colors. So we've got this green student who's not doing so hot. But again, it's a little challenging to focus both on grades and intensity of color, so let's just look at one color. This is what the visualization looks like for the class. Let's go to frequency for a moment. And I'll show you this visual. I'm sorry, I'm at a low resolution, so there's a little bit of scrolling involved. Over here we see students 7, 3, and 8 have, of their classmates, so this was set relative to the number of shared. You could do it absolutely as well, where it's the number of possible shared answers they could have. Compared to their peers, these 3 students shared the most. I took the liberty of looking at the admin records for these 3 students. Students 3 and 7 started the quiz within 5 minutes of each other. Student 7 finished a half hour before student 3. And that's what I know. Does that indicate cheating? I'm not saying it is, but that's what I'm knowing. That's what I know. So that's essentially what I have here. By the way, I ran a second data set. This is the same assessment, but done over a previous semester. And I'll again switch by frequency. And we can see in this one that there are about 5 students who share, relative to the rest of the class, a high degree of shared correct and incorrect answers. So I want to flip back to my slides and talk about this for a little bit. I want to get a little bit into what's going on behind the scenes. So this is Canvas Quiz CSV. And unfortunately, I couldn't do this automatically. So what we did is we have Excel as an intermediate, and we converted it to JSON. So we went CSV, ran the calculations, made it into JSON. And then this visualization that Mike Bostock created uses D3 as the JavaScript library. So that's what gets you the shiny pretty of that. This is what the JSON looks like. This is just a sample. So the node is declaring the student. You see the name field? That's student 0, so that's the label. The group in the original is that community detection algorithm that determines color. In my visualization, it was the final grade. So what I did for these visualizations was we took their score and just rounded to the nearest 10. So if they got an 85, then we rounded up to 9. If it was an 84, we rounded to 8. Source and target is describing the relationship of the different nodes as they appear in the JSON. So source 0 is student 0, target 1 is 1, and then value 44 is the number of shared correct and incorrect that they had. Any questions about the JSON? Okay. So we want to talk about limitations of this. One of the limitations is that inherently this visualization is about demonstrating correlation. As we know from our stats class, correlation is not causation, which is why I can't represent these visualizations as proving cheating occurred. The context is the key. And the question in my mind is who's providing the context. And my hope is that in terms of the use cases, I imagine it would be the teacher providing the context. My hope is that these visualizations would narrow down the kind of students to look at. Teachers are busy, so hopefully this would narrow down the potential students to look at. It may also absolve students under certain circumstances as well. I understand that this is a fairly big limitation of it, but I think it's important we deal with our limitations. I came across this quote from John W. Campbell. He was the editor of Astounding Science Fiction. And he said this in the October 1956 edition. The curious fact seems to be that achievements are made by discovering limitations, not freedoms. The atomic bomb works because there is a limit to the possible size of a sphere of uranium-235. And it's my hope, it has always been my belief, that the power in ed tech is when we look at both our possibilities and our limitations and turning those limitations into opportunities. I do want to close off with one other limitation. Maybe I'm self-conscious because Audrey Watters is at this conference. So as I was thinking about the purpose of this presentation, I couldn't help but find a little bit of an analogy in Les Miserables. In the story, the Inspector Javert relentlessly pursues Jean Valjean to ensure he suffered a punishment that far exceeded his crimes. When we look at cheating, it is important that we don't become so enamored in finding culprits that we lose sight of the goal, which is not to punish cheaters, but to cultivate honest students. Our best measures for doing so are creating rich and exciting courses that students are motivated to take with assessments that are reflective of their work and abilities. When paired with reasonable enforcement, which could potentially be aided by data analysis such as this, instructors can be satisfied in knowing they did their best to make the learning experience meaningful. And I'm kind of under time, so I apologize, but that you can get in line for the next one, the next presentation. Or you can pepper me with questions, but I apologize. So this is what I have. I'll take questions. My email address, I'm on Google+, LinkedIn. I'm a prisoner on Facebook, so you're welcome to reach out to me any of those ways. Any questions about this or the second visualization? Yes, sir.
You said your value was the number of shared correct and incorrect. Was that added together? So 10 correct and 2 incorrect added together would be 12?
Right. Right, so it's just a simple comparison. And if I had had more time, I would have loved to have separated the two out so you could flip it and say, these are the shared correct, these are the shared incorrect. I just didn't have time for that. But yeah, I think that would be a natural place to extend it. Other questions? Sorry, I didn't repeat. The question was, is it just adding the shared incorrect and the shared correct together? Yes, sir.
Have you had success with this, or is it a bit lickable yet, or are you just trying this out?
I'm just trying this out. I wanted to see on a couple of data sets whether this would be, whether it would be. So the question was, have I applied this and have we done it? No, but I'd certainly like to. I think it's important understanding those, being able to understand where the limitations are, and so we're not applying it. In some ways, it's not unhelpful if you've got such as that first data set. You run it, you show it to faculty, and you say, I can't really, it's hard to distinguish between students because your assessment is where it is. Unfortunately, we have item analysis here, which can, so we can have that conversation about, well, if you want to improve that discriminating power between students on this assessment, that's how this goes. I should mention also, in terms of other uses for this, the headline was cheating, so I didn't want to get into it, but potentially if you did a survey, and you were looking at for students, so rather than looking at shared correct and incorrect, you're just looking at shared answers. And so you give students a survey, you run the visualization, now you can intelligently put students together into, not that you couldn't before, but you can have a data point, a way of looking at grouping students based on their shared answers. So something like too big for a MOOC, but certainly for an individual class, you could look into that. Yes.
Have you been in discussions with Canvas to get the information that you need to properly do this?
I have not. The question was, have I been in conversations with Canvas about this? I haven't. I'm kind of a CAD. I just sort of do, and then, you know. Oh. Yeah. Yes, ma'am. As I mentioned, the key is the context. So the question would be, if it's shared incorrect, the first step would be the instructor to look. So sorry, I need to repeat the question. So the question was, how would I work with an instructor using this visualization? So what it might be is a professor says, how do I know these students aren't cheating on this? So then we look up the visualization. We say, these are 3 students there might be a question about. Let's go look at their exam scores. And so maybe then we can start comparing essay questions or short answer questions. If it's straight multiple choice, as all these sample data were, then it would be a next step of, well, you know, maybe it's just a casual email out reminding people about the academic honesty policy in the syllabus. Maybe so you just send it to everyone, not just those 3 students. It may be so it may be a specific email. Hey, I noticed your answers. Or maybe there was a report from the testing center that there was something might have happened, and so then you can look and verify. So it's sort of after the fact. So we had a suspicion already, and now we're doing it. So that would be where I would do it. Some of it would be, part of my hope would be looking at it longitudinally. So we have a couple of professors who use the same exams for the last 10 years. And if we're able to show through this visualization that not only is it the means are raising, but we're seeing, you can visually show them that they're seeing this unified. So it depends a little bit on the context. Does that help? Okay. Yes.
Along with that one, is there a place in Canvas to see where the students are coming from when they're taking their exam?
So the question was, is there a place to see where students are coming from? And I believe from the admin, you can get that. Yes.
The problem is you can get the IP address, but they're inside the entire network.
Right. So sorry, I keep forgetting to repeat that. So to repeat the question was, can you tell where students are coming from? And the answer is yes. There's IP. There's some challenges. Some universities are not. Their IP addresses could mean, they're kind of all behind one IP address or something like that, where it makes it challenging to really tell where they're coming from.
quiz data, you can do some crazy, amazing stuff to really say it's either the student answered 50 multiple choice questions without reading the question because he answered them in 3 minutes, all correct, or
Right.
he might have actually been cheating. So
Right.
the more we can get, the better.
So the comment was you can do cool stuff with IP addresses. Yeah, and yes, I agree, but the value depends on the institution. It really varies. So you can't take that to the bank. Yes.
Yeah, I just had a quick comment about the APIs. We actually have recently released the Quiz Reports API. So it's still CSV, but you can generate it from the API. So you do the API call, you can go get that data.
So the comment was the API now allows for a request for a get, and it pulls a CSV. The student or an item analysis. I appreciate that. So thank you for that. I have time for probably one more question. Yes, ma'am.
I'm trying to figure out how to mass produce this because I don't think our run-of-the-mill faculty would be able to do this type of function because of the JSON and all that fun stuff.
Right.
I know I couldn't do it. So, but how would we reproduce this?
So the comment was, how do you mass produce this? And the answer was, this was always with an eye towards being able to just click a website and generate the report. And I don't think you would necessarily need to run the report for every assessment or forever. I don't think that's a good use. I think it's working with the faculty to identify what are the high stakes assessments and then going from there. Or if they suspect, yeah. One more, and then yeah.
Just a quick question. So when you look at the right versus wrong, are you looking at which wrong answer they chose and any correlation there as well?
No, and certainly. So the question was, are you looking at which one in the distractors? And this particular visualization wasn't that sophisticated. Certainly, when you see the literature in terms of collusion detection, they go that far in terms of detecting, which ones were used, which ones were more likely to be used. Because right now a weakness of this visualization is that a true and false shared correct incorrect is counted the same as a 4-question multiple or 4-answer multiple choice. So I think you would certainly, as it grows and evolves, you would want to look into a model like that. Yeah. I think that's all I have the time for. I will be at Hack Night, so if anyone's interested in talking more about this, you're welcome to get me. Thank you very much for attending.